Hello everyone. For this circle f, we are asked to solve the two measurements of the variables x and y. First, we need to understand what are these representing. At the same time, what is the unique relationships that could be drawn from the given figure. X here is actually the length of this segment from this point on the circle to this point of intersection of the three chords. Y is also the length of another segment from this point on the circle towards the same point of intersection. At the same time, Y here is also used to describe the measurement of this similar segment. For this given example, we are just going to use the concept of the power theorem, specifically for the chord-chord power theorem. And it tells us that if there are chords that intersects inside the circle, there is unique relationship as to the portion of each chord. Let's say this is the first chord here. Okay? So since it intersects with another chord, let's say this chord with 4 and 7, there is a unique relationship as to that. First, let me just go copy this given figure here, a similar figure, but without this chord here, so that we could focus on solving for x first. And we are going to use later the remaining chord in solving for y. Now for this, as mentioned, these are chords that intersect inside the circle, as this is the point of intersection. There is a unique relationship between the segments formed that are cut by the point of intersection. And it tells us this. The chord-chord theorem tells us that the segments that are cut for chord, when multiplied to each other, let's say 8 and x, is just equal to the product of the segments of the other chord. This would mean that if we're going to multiply x and 8, this is just the same as when we multiply 7 and 4. Again, the segments that are formed here, x and 8, when we multiply it, they are segments of the same chord, is equal to the product of the segments of the other chord, 7 and 4. So we can use this to solve the value for x. That would mean x, or 8x, is equal to 28. And then we're solving for x, divide both sides by 8. Divide both sides by 8. You will get a result of 28 eighths, or in lowest term, that's 8. Or in lowest term, that's 14. So not 14. Divided by 4, that's 7 halves. So this is the value for the segment which is labeled as x. Again, we use here the chord-chord theorem, where again it tells us that the product of the segments of one chord is equal to the product of the segments of the other chord. Now that we are done with this, let's go to y. Now, there is a advice here, since there might be chances that your solutions might be incorrect. So let's just use the other chord here that could be paired with the chord containing y. So let me increase this portion here a little bit better. So I could insert another circle, which will actually just involve the given values of the chord, which is already given, and the chord with y variables. I did not use the value or the chord with x, even if the value is already solved here, because there might be chances that if we're going to use that, and if it's incorrect, it will also make the value of y incorrect. So for this, let me continue and use the same concern. It tells us, again, that the product of the segments of one chord, let's say this and that, is equal to the product of the segments of the other chord. So you will have here y times y minus 12. when we multiply the segments, must be equal to the product of 7 and 4. Using algebraic processes, you will have y squared minus 12 is equal to 28. Since our equation is now quadratic, we can come up with a quadratic trinomial here by subtracting both sides by 28 so that the other side will become 0. And factor out this quadratic trinomial, and if I am correct, the factors are y minus 14 and y plus 2 equal to 0. Let's just check. FOIL method, y times y squared. Outer, y times 2 is 2y. Inner, 14, negative 14 rather, times y is negative 14y. When you add them up, sorry, there is y here. That's 12y. And then negative 14 times 2 is negative 28. So this is the factor. So we have two values for y by the zero factor property. Y minus 14 equals 0. So your first value for y is 14. The other value for y plus 2 equals 0, is y negative 2. These are the two values that you could use in solving for y. However, take note that y is a measurement of a segment. Hence, we do not accept negative measurements, so we only have 14 as our value for y. So that would mean this is 14, and if we're going to compute this other one, 14 minus 12, this should be 2. So this is how we solve the values of x and y. Earlier, x is 7/2, already checked. When these three chords intersect at the same point of intersection inside the circle, F, using the Chord-Chord power theorem.